Okay, so welcome everyone to another exciting episode of the Women in AI Research podcast. My name is Ekaterina, and I'm joined here by my co-host Malika. And today we have a very remarkable guest, Aparna Balagopalan. She is a final year PhD student at MIT, and her research is centered on developing fair, interpretable, and robust machine learning systems, especially within the domain that is sensitive and socially relevant, such as, for example, healthcare. Aparna, we are delighted to have you here today with us.
Thank you for having me.
Sure. Aparna, I would love to hear a little bit about your journey, and specifically, you have an interesting career trajectory. So you have started as a research engineer in the industry, and then after some time, you have transitioned to a PhD program.
Yeah.
So I would love to hear what has inspired that shift and how the journey unfolded.
Yeah, sure. So I guess I started my research journey when I started doing my master's degree at the University of Toronto. I was in the MSc program, which kind of has like a co-op component, which is essentially you work at a company for a few months to see and like do research on a specific project. So I guess that's when I got my first entry into like research project, working on a research publication where I work with Ekaterina, which is a great experience. So I guess I really loved doing research there. I loved the process of coming up with a research idea, like testing hypothesis, and then like writing it up as a publication. And I realized that that's something that I kind of want to work on for a long time. So I guess that was the motivation to apply for a PhD program. And I think like generally, like I always even for doing research, I was always wondering what specific area I would focus on. So I really found the area of machine learning for healthcare very interesting and relevant. So I could see myself kind of working in that space, doing research in that space, which is why I applied for PhD programs.
Amazing.
That's such an intriguing transition. I'm curious, as you worked both in industry and also academia and experienced research in both environments, what differences have you noticed between doing research in industry versus academia?
Yeah. Honestly, I'm really glad I did some research in industry because I feel like research is such a complex process. And in industry, at least where we worked, it seemed like we thought about breaking down the research project into like concrete like sub goals and like tasks that we could like test, which was I think really helpful background as somebody coming into like a PhD. I think without that background I would have struggled a little bit more in the beginning, I feel like, though eventually I guess with PI's help we all get there. And I think the other kind of difference is in industry a lot of the times the research is tied to some product goal, which means there's like some sort of scope in which the research project should eventually be like deployed in practice in mind concretely when we potentially start with a research project. And that's not always the case. I think in academic setting, there's always a practical application at hand, but I think there are a few steps that's further removed from like the more product oriented research that usually industry sees.
Yeah, that's true. I totally agree. And as you're getting close to the end of your PhD, what are your plans? Do you plan to return to industry or stay in academia?
Yeah, that's a great question. I have a broad approach right now. I'm on the job market, so I'm looking for positions both in industry as well as academic positions. So I've been interviewing for postdocs in the academic track, and I've also been kind of interviewing for industry positions at the same time.
That sounds like a good approach, I think, to to keep your options open. In general, I wonder if you don't mind me asking,
Mhm.
you probably had both ups and downs during your career. And there are many places, many time points during the research journey, during the career, when you need to make some difficult decisions. Also, obviously, there are time points when you just achieved something and that's exciting. But then I think you or everyone tries to share it with everyone else anyways. But in terms of those down points, that's something that people usually don't hear about too much. So can you share with us what was maybe some really difficult decision that you had to make during your career with regards to your career?
Yeah, I guess like definitely there have been like really difficult points. I think the decision to kind of like pursue studies like education like outside like India itself was kind of difficult because it's like, I had never lived for more than a few months like outside India, and it would have been like it was a completely new setup, and you're kind of starting from scratch in a new country, and you're expected to like do classes, potentially do research, and also like get to know who's this. So I think that was pretty challenging. In the research process itself, during my PhD as well, there were like definitely hard points. So I think that I was so excited to do a PhD that in the first year, I definitely overworked myself too much to the point of like near burnout. So I think the solution there was, I guess it was hard to do at that point, but just to kind of like take a break. I feel like my research progress during the first year, I guess putting output during my first 1.5 years was relatively low because of that. Because I feel like I realized that I was taking on too many projects and not being able to like complete the projects because of kind of like too much, taking on too much at a time. But and this is like because of self-imposed pressure, not because of any other thing. So I feel like at that point, just like taking a break, learning to kind of focus and kind of do better time management, often like doing like non-research tasks to help your brain kind of like grasp things better. I think that was also kind of like a slightly turning point, I think.
Yeah, thanks for sharing your experiences. I think my question is also somehow relevant to what you said. I'd like to get a glimpse into your daily life. What does a typical day look like to you as a PhD researcher in AI? Especially these days, I wonder how you manage to navigate the rapid pace of AI while keeping
Mhm.
a balanced daily routine.
Yeah, yeah, no, that's a great question. I feel like that is something that I've definitely struggled with, and I'm definitely still struggling with, but trying to do my best, which is like have a more balanced situation and like research and have like a better work-life balance. So generally, like to do that, even though once you are done with your coursework, your PhD schedule is pretty flexible, but I still try to like go into the office to our lab space like for like fixed duration during the day and try to do like most of my work there. So that's kind of like what the daily schedule looks like. And in the evening, I like to kind of like relax with like reading or like hanging out with people. And also like I think during my PhD, I've also tried to explore a bunch of different sort of like workout activities. So I've tried like dancing, I've tried boxing, which is the latest one. So
Oh,
I feel
wow.
like, yeah, it was actually a really good friend who got me into it. So I think that also helps you bring in a little bit of balance.
That's great. That sounds really interesting. And I should apply a couple of your insights to my own life, maybe even boxing, who knows? Yeah. You mentioned previously that you are from India yourself, right?
Mhm.
And you moved to a different country to study and work. So you have studied and worked in Canada, and then you moved to the US, where you are right now, right? To do your PhD. So it's you have quite of the international background. And
Mhm.
I wonder, do you feel any influence that international background made on your research, on your interests?
Yeah, I guess like definitely, I think a little bit of perspective is brought into the picture when you kind of are interacting with like different, like, I guess the research environment in different countries, as well as just like generally sort of like the process of like doing research in different countries. But I think like across, say, India, when I was doing, I did very little like research in India. It was very much focused on coursework. So, in terms of coursework itself, I didn't find too much of a difference. But I do think that, like, the opportunities and exposure that universities here get, US and Canada, I think are like much, much greater. So, I do kind of like recognize the privilege that I had. Even in India, I was in like a good university. So, I had like the path to potentially do a PhD or potentially apply to a master's program. But it's really hard if you don't have that. So I think there's definitely like an opportunity difference in access, but I think that has helped me like influence my research and the actual like research projects as well. Often when you're working with like data, real data, you think about like systems being not just like US centric or like Western centric. You also think about systems in say India. So I think that is also like useful perspective, though I do mostly work on like data sets from the US so far.
Right. But I think it's a very different perspective that you have by default anyways, and that's something that probably needs a little bit of more of emphasis anyways, even within our like Western centric
Yeah.
research.
Yeah, thanks for sharing your experience. So, from another perspective, I wonder, as a woman researcher in AI or in tech in general, how you saw the contrast between these like different communities, cultures.
Yeah.
Yeah, that would be great to hear from you.
Yeah. I think that like honestly, for me, I have not faced a lot of like differences because I think that's just because I've had like supportive environments in all these like different research environments. But I don't think that's the case everywhere. So I do feel like sometimes there are like systemic issues. There are places where like, you know, women do find it harder to do the same task, not because of anything that is like different, but just that there are more barriers often. So I think in that sense, like I'm lucky enough to not have faced too many of those across these different research environments, I think.
Yeah, that's really great to hear that. Fantastic. I think that's the time to let's dive into your research focus a bit. You have a very interesting paper called Machine Learning for Healthcare That Matters.
Mm-hmm.
A large part of your work has been in machine learning for healthcare, and this one was really interesting piece of research work. In that paper, you emphasized that the tangible impact of machine learning in healthcare has been limited despite
Mm-hmm.
significant technical advances in the field. What are the reasons for this, in your opinion?
Yeah, that's a great question. I should say that that paper was actually kind of like a very interdiscipline, like I guess like across institutions collaboration. So we're all kind of like it was just kind of a discussion form that over multiple meetings like made its way into a paper. And a lot of the writing was done by Liam for the paper. But generally, I guess through the discussions, like the one of the motivating example that kind of drove some of the discussion was that during the early years of the COVID-19 pandemic, there were many detection models developed basically to like detect COVID from chest x-rays. So the input would be a chest x-ray and the output would be like if somebody whose chest x-ray that is has COVID or not, COVID-19 or not. But when it came to actually like using those systems in practice, this was in an article. Essentially, a lot of the systems failed in practice, potentially because the data quality that was used to train those machine learning systems were not good. So very often the healthy cohort was that of kids in one specific example. So the model was learning to rely and learn not just like features of COVID, but kind of age-based some sort of decision. In some other cases, like the model learned to associate like spurious correlations in the data and try to rely on that for the prediction task. So data quality was definitely like a big issue there. So generally, like thinking about the data that makes up machine learning models, as well as like how such models are deployed, what's the actual like clinical goal. I think those components have to be thought about a little bit more, and those are some challenges we're facing today.
Right. So you mentioned data quality several times, and it's definitely a big issue because like the quality of data is probably one, if not the only, it's one of the really important parts of the quality of the model that was trained using that data as well. I wonder how much you think it's about the quality itself, which is
Mhm.
probably a bit of a broader concept, versus the bias
Mhm.
in that data and the diversity of the data. Can you can you recall some of the examples from maybe different projects that you have worked on, or was it more specifically to that project that you are speaking
Yeah.
about right now?
Yeah, that's a great question. I do think that so a lot of my PhD research is on this. So this is basically like in my research, I'm thinking of machine learning as like a pipeline, and I'm thinking about how different components of the pipeline impact reliability. So reliability could be robustness, fairness, overall accuracy, and data is definitely one important component. Biases, yes, the biases can like creep in how we select the data. For example, we're only selecting data from specific hospitals and like really well-funded hospitals. And when you're training systems on that kind of data, those models might not work in, say, another hospital, even if the system is like relatively similar. It's related to how we have like if it's a supervised setting, the labels. So there might have been historical biases that impact historical decisions. And if we're just learning to replicate those, we might have like less reliable models. That's definitely like the data, I think, is like an important component. But then you also have like the model component, which is what you choose to optimize. Very often we choose to optimize the average performance, things like empirical risk minimization, and that might not be the best optimization objective. So I think there's also lots of work in like choosing a better loss function, say looking at like subgroup level performance to have better models. And then I think finally you also have a deployment perspective, which is even if you have kind of a good model that is reliable and robust, the way that you show it to end users also really impacts the final decision that you make with the model. So if that process is biased in some way, then you would have potentially incorrect decisions in the real world. So I think like thinking about those components is one thing that I'm hoping to finish in my PhD thesis.
That's fantastic and very insightful to look at the problem from both perspective of like model side and also data side. What about other structural issues? I think you covered many of those, but there is one particular part in your paper that you share an interesting observation that emphasis on targets that are easy to measure but not be like clinically important. Could you elaborate
Right.
more on this?
Yeah. So I guess like there are like I guess two perspectives that in the paper that we write about. One is like again like what we choose to optimize. Very often we have like a data set and we just like look at like accuracy. So the target for optimization might not necessarily be accuracy. It could have been something different. And the second part is we also talk about this in the paper, where basically we want to do machine learning for healthcare, not machine learning on healthcare data. So understanding the problem at hand and like working together with like clinicians, nurses, doctors to actually understand like what would be helpful to them and what is the goal that they're aiming to achieve with the machine learning model at hand, I think is important. I think that's what was like emphasized there.
Right. That sounds interesting. Hear you that in terms of collaboration with the actual users, right, with the
Mhm.
doctors, it is worth to communicate with them more closely and to really understand the task in hand. And that, as far as I understand, is one of your recommendation on
Right,
how to improve this area.
exactly.
What about those metrics that you have mentioned? That
Mhm.
sometimes the metrics are also the issue because they are used without understanding them clearly. Do you have any recommendation on how it could be possible to improve in this area?
Yeah, that's a great question. I think even that, ideally, the metric selection should be informed by discussion with like stakeholders, like doctors, clinicians, often even like patients. And I think, for example, if you're trying to like diagnose a specific decision, you might care more about correctly identifying patients who actually have the disease. So instead of like accuracy overall, you might want to look at metrics like true positives or false positive rate or false negative rate, in fact, might be more important here. So I think like choosing that metric to evaluate models, I think is really important.
Sounds good.
That's great. Yeah, very great insights. I have never looked at it from that perspective. Fantastic. Thanks for sharing that. Going to another beautiful research work, one paper which is called Judging Facts, Judging Noise. So I'd like to discuss your research on developing fair and robust machine learning models, especially in the sensitive area of healthcare. You have one science paper, as I said, Judging Facts, Judging Norms. You presented a very fascinating observation about data annotation in particular, that data annotators labeling objects differently depending on whether they are asked a factual question or a normative question. Can you explain how you arrived at this insight? And with that, what's its impact on model fairness and model robustness in different scenarios?
Yeah, that's a great question. So, actually, the background of the project is that this project was developed even before I even started my PhD. My advisor, along with other professors, Dylan, Jillian, and some other like students, David Madras and David Yang, they kind of had started working on this project, which is they were trying to identify when you can accept explanations of models, like thinking about explanations that models provide as justifications for some decision. So I think the project started off with the goal of like tying, like if a model is making a specific decision, it should be based on facts, and those facts should be presented as explanations. But then when they conducted the study, the initial sort of pilot study, they found that judging the presence of something in an object. So, for example, one scenario that we had was we had a picture of like a bowl of cereal. And if you ask lots of annotators, does this bowl of cereal have high sugar content? Like a majority of them said that it did. So, that was just a factual question. But if you have a normative context that depends on the very same facts, you get kind of different judgments. So if you ask a different set of annotators, we have a school meal policy that prohibits meals with high sugar content. Now, does this bowl of cereal have violate the school's meal policy that is violated if there is high sugar content? And here only like a small proportion of annotators said that the school meal policy was violated, which means that a fewer proportion of them thought that it contained high sugar content. So there was some difference in the way that annotators were judging facts versus norms. That's kind of, I guess, once I joined the project, that's what we were testing. That's the hypothesis that we were testing, that people judge the presence of facts differently versus the norm violation related decisions differently. And this is really important because this assumption of like the fact based, what we call descriptive labels that can be repurposed for normative applications is very prevalent nowadays in systems nowadays. So, for example, we have toxicity classifiers that classify if like text is toxic or not. And then we deploy them on like online platforms to decide if like a discussion forum policy is violated or not. So that's more of a normative setting, while very often the training data is descriptive. So it has, I think, real world implications. So as to data like fairness perspectives, we didn't really look at that in this work, though we did observe that if you were to use descriptive labels for normative applications, the performance for some groups were lower than the other groups. So there are definitely like fairness implications probably, but we didn't really test that much in our study.
That sounds really interesting because it's all about the question of whether we can trust the data sets that we consider to be ground truth.
Exactly.
And usually just the name ground truth means that it should be the absolute truth, and it's not necessarily the case. I wonder in that project that you speak about right now, whether you have found, and in general, what's your opinion? Do you think that those differences in labeling, they can be caused by cultural differences or some demographic differences or something else? What do you think is the main reason?
Yeah, so we actually tested for that. Like we control, like if we like all this data collection was done on Amazon Mechanical Turk. So for a subset, we actually did have demographics, and we kind of tested if the differences were driven by demographics. But essentially, even adjusting for that, we still saw a difference. I think definitely like the background of annotators play into how they label. There's, I think, lots of work showing that. But in this specific case, it was probably because of how people judged the cost of specific like facts being true. If a meal had high sugar content in the descriptive data labeling, I guess there was no, annotators had their own like cost of like saying that it had. like a high sugar. Sorry.
Is it something like the implicit understanding of the consequences of your label?
Exactly. Versus exactly in the normative context, like potentially like a violation affects something or somebody. This is something that we didn't like. I don't think this with the study we can explain the reasons for the difference. That could potentially be a follow-up study. Here, we just kind of showed that they were different.
Yeah, that's super interesting. And also, as a follow-up question, I want to ask you, usually the majority of your research, as far as I know, is both within the context of healthcare, machine learning, and also within the modality of text, right? But I know that you have also worked with different modalities as well, such as, for example, vision. And you have that recent work that is the paper that is called Lemon, Label Error Detection Using Multimodal Neighbors. And you also analyzed the label errors in multimodal data sets
Right.
in that
Right.
work. So can you first of all tell us a little bit about this work as well, about multimodality? And I'm specifically interested whether you have noticed any differences or any similarities across modalities when it comes to incorrect label errors.
Yeah, that makes a lot of sense. I think I'll briefly talk about that work first. So with that paper, we're essentially trying to develop a method for automatic label error identification. So a lot of the pre-trained models today are trained on data that is scraped off of the web, which means that labels might be noisy, but the size of these data sets are so large that you can't automatically like go in and say that, hey, this label is wrong or this label is correct. So this kind of like automatic label error detection where the input to models is essentially your instance of interest and then a label, and then the output is like a binary prediction or a score indicating like likelihood of label error. Those systems are really important. So what we say is that when you have a vision language model, a pre-trained, contrastively pre-trained vision language model like CLIP, you can embed both the instance of interest as well as its label. Its label can be like a text string. It can be a classification. It can be a classification index mapped to the group name, or it can be like a caption that describes, say, if it's an image, what's in the image. You can embed both the instance and the sort of label into the same representation space, and you can compare these two representations. This has kind of been done in prior work, which is like a CLIP similarity score for images and labels. But you can also look at neighborhood information, which is identify if we have two components in our paper that we explore. One is retrieve neighbors in the image space and see how close captions of those image neighbors are to the caption of the instance of interest itself. And similarly, also retrieve neighbors in the image space, in the text space, and compare how similar the images are to the image of interest itself. So with this, like we're getting like a closed form score. And we're saying that when the score is higher, there is a higher likelihood of label errors. And we validate the score in the paper. And we also test how, if you remove data points predicted to be label errors from your downstream model and you train your downstream model on these sort of like cleaned or filtered data sets, does your performance improve? So if you are training like a captioning model, first you would run Lemon on the whole training data set and only retain instances that are predicted to be correct. And then you train your captioning model. Is that better than training on the whole, like sort of like unclean data set or data set with some noisy labels? And we find that that is the case. So yeah, that's kind of like the high level summary of the project. And in terms of the second question, which was related to data modality, quality, or like label errors. So in this specific paper, we looked at vision language joint modalities. So it was the instance being labeled was the image, and the label was like it was text essentially. So we make the underlying assumption is that the image modality is correct. The instance that is being labeled is correct. And the noise is in the text modality. This might not be true. Image might be noisy. Maybe some part of it is missing. I think those are all kind of like interesting directions to explore in future work. I think related to like which modalities have higher label errors, I do think there's like a task dependence there. Like it is potentially tied to how difficult tasks are, I think, in the labeling task, I mean. So yeah, I guess like it would vary across the context of the task.
Yeah, interesting. Yeah, that's great. Somehow relevant to what you said, the question I'm going to ask, but from your experience or maybe the other research work that you've been through, what are the like substantial similarities or differences between modalities when it comes to responsible data challenges? Because in healthcare, many different modalities are involved, as you said, audio, vision, language. So do you see any things in common or not in common?
Yeah, I think regardless of the modality, I guess there is definitely like label noise. There's definitely issues related to data sets being from specific settings and not generalizing to other settings. So, in kind of my research, I've worked mostly with tabular data as well as image data as well as text data. So, I think I've seen some of these issues across modalities. So it's a really hard task, I think, but collecting data from like lots of environment scenarios, thinking about like goals, apart from just performance in a specific setting, I think would be one way to improve there.
Maybe one more follow-up question about this specific area of research about label errors, their identification, detection, mitigation. You have mentioned that it is not necessarily generalizable across
Mhm,
different types of tasks.
mhm,
Can you elaborate a little bit more here? What is your intuition? Are there any groups of tasks
mhm.
or types of tasks where you could expect similar errors, or it's completely like it's very difficult to expect any
Yeah.
pattern?
Yeah, that's a great question. I think like there's in terms of reliability, it could be in terms of like group level performance, like you said, so like more related to the notions of fairness, where you might have imbalanced data sets. So for example, you could consider the race of patients in a data set, and that might be really balanced across different racial categories. So then you might have really low performance on subgroups that are less represented in the data. So I think that is one scenario. The other one kind of example that comes into mind. The other sort of robustness issue is when data sets or models learn, data sets are kind of, I guess, don't consider all potential environments, and models learn to rely on spurious associations. So I guess one example in this space is when you're trying to, I think the task is like trying to distinguish between camels and cows or something like that. It's a classification task. And all the camels are in deserts. So when you have an image of a camel in like I don't know, in
Blue.
grass, the model fails because the model is learning to detect grass instead of like actual features of the camels. So I guess like one way to solve it there would be like collect examples or add examples of like camels in the grass and cows in the desert and add them to the data set, or like modify the loss function in some way. So yeah, I guess like that's another aspect to consider.
I see. Interesting. Interesting. And thank you for this great overview of all the different types of research that you have done during your
Of
PhD and
course.
even slightly before. So now, as we wrap up our conversation, I'd like to ask you one question that many people find sometimes difficult, but it's a really important question, I believe. What would be one piece of advice that you would give to the young women that are entering the field of artificial intelligence? Maybe from your personal experience, what was the mindset or approach that have helped you the most in navigating all the challenges and making the impact? I think that would be the best advice as well to those
Yeah. Yeah,
people.
yeah, thank you. I think that's also a great question. I feel like, again, as I said, like, I think for me, I was lucky enough to have like a supportive environment, often with like a lot of like women like you, Katrina and Malike, and my PI, who have really like, I guess, been great mentors and kind of shown that, we can do research and we can do good research. So I think I've had positive examples, but I think there are definitely like structural barriers that women face across like countries, like research contexts. So it's definitely hard. But I think like if one key thing that I try to do is believe that I can do the research, I'm just as capable as like the next person. And especially in settings like academia, everybody is really smart, as well as industry, academia, industry, anybody doing research is really smart for sure. But I think like thinking about when you're choosing to work with some specific people, like think about how much you would gain from the collaboration from a research perspective, but also from a mentorship perspective. And if you would, I guess, have like a good project experience. So work with people who also have similar goals, for example. Um, and I guess like one other important component is as we progress in our research careers, I think it's also important to like pay forward. So essentially like things like what you both are doing with the podcast, I think those are really great initiatives. And similarly, like I know that in our department here, as well as in Toronto, there were mentorship sessions encouraging undergraduate students to consider PhDs, graduate careers. So I think like participating in mentoring sessions like that, those are definitely some things that would help make a better environment for future researchers.
Right. So to summarize, mentorship, role models, and our podcast, right?
Yeah. Yeah. So I think one other point that I'd also like to suggest is like building more diverse teams. So I think that's something we say in the machine learning for healthcare that matters teams as well. So including diverse perspectives also kind of helps improve the overall like field for lots of future researchers.
That's a great insight, and I completely agree with that.
Yeah, that's great. Thank you. Yeah, I really agree also with the point of collaboration. I think that's the key to success. Sometimes you put a lot of rock stars together in a team and it fails, but a nice collaboration really is like parallel processing of different brains together. So that's
Yeah, 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 yeah.
ahead. What do you see as the most exciting or transformative development in your field of research?
Yeah, I think like we've seen lots of systems being kind of proposed, but now I think we're actually seeing some systems potentially being like deployed in practice at a higher scale than they were before. So one example is like language translation systems. Now, language translation systems are often used in kind of hospital settings, so to help like different patients communicate with the doctor. So I think that is something that I'm really excited about, like actually like thinking about the challenges of deploying systems in practice. And maybe in some cases, you shouldn't deploy a system in practice if it's not like well built or reliable in some cases. Maybe machine learning is not the solution there. But when it does seem like a good solution, like I think that transition, thinking about like human perspectives, kind of user interaction and improving like the whole, again thinking about the whole pipeline perspective, thinking about actually having systems in practice, I think is it's very exciting.
I think that's the great suggestion not to use machine learning absolutely everywhere. It's a great tool, but you need to know when to use it.
Yeah.
Yeah, sounds great. So yeah, I think we can wrap up now. So thank you so much, Aparna, for joining us and for sharing all the insights that you have and for sharing your experience and your incredible journey.
Thank you so much. Yeah, thank you so much for this opportunity.
Awesome, absolutely. This has been incredibly inspiring. Thanks again, Aparna. So, for our audience, feel free to drop your questions on our YouTube channel or under our social media posts. We'll get back to you very soon. Stay tuned for exciting episodes coming soon. See you very, very soon.